Good morning, afternoon, whatever time it is of the day that you are in my class. If you're watching this, I'm at home with my baby and my wife, and we are just living it up and not sleeping much probably, but hopefully we are. Let's get down to it. When we come back in January in 4th grade, we normally start learning fractions. Now, at the beginning of this year, I kind of preloaded you guys with some information. We did a lot of number sense with fractions. So I'm hoping you guys have a little bit of knowledge with fractions. And I saw on your fraction screeners that you guys did understand a little bit, but there's a whole lot more that we can learn. So let's go ahead and get to it. These are called Cuisenaire rods, I believe is their name. We're going to use these to develop some fraction sense. Let's remember some vocabulary. The word whole. Notice this has a W in it. Doesn't want to focus. There we go. This has a W in it. This is not a hole, as in something you fall into, okay? Hole, something you fall into. That would be H-O-L-E. Whole is like the entire thing. It's a whole pizza. It's a whole hamburger. It's a whole whatever it is that you have a whole thing of. Okay? It's all there. None of it is missing. That's a whole. If I were to ask you which one of these represents a whole, which one would you say? At this time, please have the substitute pause the video. Hopefully you had some time to discuss which one you thought was the whole. Some of you may have thought that this was the whole. Some of you may have thought that this was the whole. Some of you may have thought this was the whole. Maybe some of you even thought that was the whole. I don't know. Truth is, none of these are the whole. Any of these can also be the whole. It all just depends on the context. That's one of the important things about the whole. Whenever we're calling something a whole, our whole needs to be, especially when we start comparing, we need our whole to be the same size. So if I say, if I take this and I say it's a whole, this maybe looks like 2/3 of the whole. I'm thinking this might be about a half of that whole, right? Because I think I could take two of them and make a whole from it. Yeah, pretty much. Yeah, two of these makes one of those. But if this were the whole, this blue one here, if this were the whole and I were to compare one of these to it, is the yellow a half? If we lined up two of the yellow ones, is it going to make a whole? No, not quite. So there may be one in here that is a half of this blue one. Let's try this purple one. See if it's a half. Not quite. I don't know if I have a half of this one. That doesn't quite seem to fit either. Maybe the black one. No, that's even longer. So I don't know that I can do half of this one necessarily. But maybe I could see how many of these. How many red ones do you think it's going to take to equal the blue one? We have 1, we have 2, 3, 4. Uh-oh, it's not quite making it either. So it's not perfect, but maybe as we experiment, maybe this will be a portion of this one. And it is. How much of the orange Cuisenaire rod is one of the red Cuisenaire rods? Pause the video, please. Well, let's see. It takes 1, 2, 3, 4, 5 of these red Cuisenaire rods to equal one of the orange Cuisenaire rods. Therefore, this is 1/5 of this. And in this case, this will be our whole. What if I said this was the whole? Because it's not labeled. What if this is the whole? how much of the whole is this white one? Is it 1/4, 1/5, 1/2, 1/3? Well, it takes 2 of these white cubes, or Cuisenaire rods, to equal one of the red ones. So this white cube is 1/2 of this, making that the whole. But then this red one, does it equal anything here? This red one is 1/2 of the purple one. And if this is 1/5 of the orange, I wonder what it would be with the black one. Oh, it doesn't quite line up. But maybe I can make something here. Okay. So if I have one of these, and if it takes 2 of these to make one of these, that means I have 1, 2, 3, 4, 5, 6, and 7 of them. So this would actually be 1/7 of the black Cuisenaire rod. Now, we don't talk about sevenths in 4th grade. In 4th grade, I'm going to pull some fraction tiles out now. Actually, no, I'm going to pull these out because they're all ready to go. In 4th grade, we talk about wholes, halves, thirds, fourths, fifths, sixths, eighths, tenths, and 12ths. All right, what is the first thing we notice about all of these? Hopefully you noticed that all of these, when they have all their parts, are the same size as the whole. Okay, 2 of these halves makes a whole. 3 of the thirds makes a whole. 4 of the fourths makes a whole. 5 fifths, 6 sixths, 8 eighths, 10 tenths, 12 twelfths. If we had hundreds, it would take 100 of those to equal a whole. Okay, but this has a 1 on it. These are not the same whole. I couldn't say that one of these is half of this, because if I line them up, if I try to do it, it's not going to work. So the whole, when we're comparing here in a little bit, or in a couple days, the wholes have to be the same. You can't compare a grape to a watermelon. You can't compare half a grape to a watermelon, or to a half a watermelon, because they're not the same size. It's not fair. It's got to be equal. It's got to be fair. Okay. So these are the fractions that we'll be talking about. Right here, I have 1 piece. Now it says 1/5 on it. But if it didn't say that, we could still find out that it is 1/5 because compared to a whole, it takes 5 pieces of this size to equal 1 whole. Now what do we call it if I only have 3 pieces of this size? Well, if I take these apart, one of these pieces is called 1/5. And I have another piece that is 1/5 of a whole. I have another piece that is 1/5 of a whole. If we count these, we have 1, 2, 3 of them. And each of them is called 1/5. So we have 1/5, 2/5, 3/5. So when we combine them, we have 3/5 of a whole. That means we have 3 out of 5 pieces. See, it just takes these 2 other pieces to make 1 whole. Now, to write this, we want to think about this here. I'm running out of space. We want to think about this. You've seen fractions written before, and we actually see them very small here. But to set up a fraction, to write it numerically, we're going to use a fraction bar. Okay? This is the fraction bar that separates the numerator from the denominator. The numerator tells us how many parts of the whole we actually have. The denominator tells us how many parts make up the whole. So in this case, when we look at 1/5, our numerator is 1. The light is hitting it just wrong. 1 is our numerator. So we have one of these parts. The 5 tells us that it takes 5 parts of this size to make a whole. And we saw that earlier. When we combine all 5 parts, it equals a whole. Okay? Numerator, how many parts of the whole you actually have. Denominator, how many parts make up the whole. And they're separated by a fraction bar. Let's do some practice at identifying these. So I have a whole here. And I have some parts here. What size, how much is represented by these blocks here? Well, we can't be 100% sure unless we have the rest of the blocks, which fell on the floor, of course. Give me one moment. All right, we're back. I have 2 parts. Does that mean that these are halves? Well, they can only be halves if it takes 2 of them to equal the whole. Halves would be this size. These parts seem to be smaller than halves. Let's add another of these. Well, we have one whole here. If we compare these to the halves, it takes 3 to make 1/2. So what could this be? What if I add another group of 3? How many parts of the blue parts, how many blue parts do I have? 1, 2, 3, 4, 5, 6. It takes 6 of the blocks of this size to equal 1 whole. So what size are these? Well, didn't want percentage. They're 1/6. And I have 1, 2, 3, 4, 5, 6 sixths. And that's equal to a whole. All right, so let's write that down. So I have 6 parts, 1, 2, 3, 4, 5, 6. I'm gonna write my fraction bar. And then it takes 6 to equal a whole. So we have 6 sixths. If I have only 4 of them, I'm still using sixths, so I'm going to write a 6 as my denominator, but I have 1, 2, 3, 4 of these sixths. Okay? I have fifths. It tells me they're fifths. If I have all 5 of them, what do they make? A whole. But if I only have 3 of them, what's my denominator going to be? That's the bottom number. What's my denominator going to be? Right, it should be a 5, because it takes 5 pieces this size to make a whole. But I only have 3 of them. 1, 2, 3. So I'm going to write 3 to tell the number of pieces I have. I have 3 pieces out of 5 pieces. 3 fifths. Now notice, the more parts there are, the smaller they have to be in order to cover the same space, the same length as the other pieces. 1/2 compared to 1/10, even though we write it as 1/2 and 1/10, even though 10 by itself is a larger number than 2, 2 tells us that it takes 2 pieces of this size to make a whole. 10 tells us it takes 10 pieces of this size to make a whole. So in this case, the 10 is actually telling us that the piece is smaller. That's an important rule we can remember. Overall, if we're talking about unit fractions, these are unit fractions. Unit fractions are the smallest parts that make up a fraction. So in this case, 1/10. If I have 4/10, my unit fraction is still 1/10 because that's the smallest part that makes up the whole. In this case, my unit fraction is just a whole. With eighths, my unit fraction is 1/8 because that's the size pieces I'm working with. So back to the tenths. Good grief. Back to the tenths. I have tenths. So to represent this, I'm going to write a 10 in my denominator, fraction bar above it, but I need to know how many there are to write it in the numerator. 1, 2, 3, 4. So I have 4 tenths. What fraction is represented here? Good. 1, 2, 3, 4, 5 twelfths, which we would write as 5/12. What's the unit fraction that makes up this fraction? Good. 1/12, because that's the size of the smallest part that makes it up. How many of these would it take to make a whole? If you said 12, you're correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And when we compare it to our whole, it's the same. Now it's important to note there are other ways to represent fractions. This is a whole. It's a circular whole. Once again, not a hole you fall into, but a W-H-O-L-E whole. These are halves of this whole, and upside down. They're halves because it takes 2 parts of this size to equal the same size as the whole. I have 1/2 of a whole here. These are tenths because how many of these size parts equal 1 whole? Well, 10. When we have 10 together, it equals the same as a whole. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 tenths make a whole. 2 halves make a whole. 6 sixths make a whole. 4 fourths make a whole. If you have all of the parts, no matter what size those parts are, if you have every single one of them and none of them are missing and you don't have any extras, you have a whole. If you have 99 99ths, you have a whole. 800 800ths, you have a whole. All that it's saying is that you have a whole and it has been cut into equal size parts. Okay? Now you guys are going to mostly be working with these fraction bars. We call them fraction bars. This is a whole. As we line them up, we notice that when we combine all the like pieces, they all equal the same length as the whole. So then 4 fourths, 5 fifths, 6 sixths, 8 eighths, 10 tenths, 12 twelfths, and on and on. Today, I want you guys to use these to complete this worksheet. Now, I imagine this worksheet will be probably pretty easy because almost all of this is review from 3rd grade. But let's look at the first one on this side. We have a circle, and it has been partitioned. That's a big fancy word to say split in half. The curtains between mine and Miss Rawls' room, they're called curtitions. We may have talked about that before, but they're called curtitions because when the school was built in 1970, the teachers, from what I hear, the teachers were supposed to be doing a lot of co-teaching, so it was very helpful to be able to open the curtitions that partitioned the rooms into halves to take away the half and make it one whole. This is a whole circle that has been partitioned into 2 smaller parts that when combined make a whole. Well, this, they've kind of filled it out for you, but it says some questions like, or some statements. This circle has how many equal parts? 2. So you would write 2 in here. It is divided into, we call these 2 halves. One part is called 1/2. I want you to go through the rest of these and notice how there are different models for the fractions. It doesn't have to be a circle, doesn't have to be a rectangle, doesn't have to be a square, whatever. There are different models. But you're going to tell how many parts, equal parts, make up the whole. Tell how many, what we call those parts, and then tell what the unit fraction is. Do that on this side. And you can use these to help you decide the answers. On the other side, you're going to use some colors. It tells you to color 3 parts red. So you're going to color 3 of these red, color 4 parts blue, color 4 blue, and color 1 part green. After that, it asks you what fraction of the whole circle is red. So if you colored 3 of them, you're going to have 3 parts that are red. You've just got to decide based on the number of parts that make up the whole what the denominator will be. So it would be 3 over something. And what fraction of the circle is blue? 4 over something. And then 1 part green, 1 over something. You're going to do the same for the other 3. And when you have finished this, make sure your name is on it and turn it in. This will be for a grade. Good luck. Do your best.